Complete the following, they say, by writing coordinates for each of the points represented by the letters over here on this grid. These are Cartesian coordinates, which means it's two numbers, one after the other, and the first number tells you where you are to the left or right. A positive number means you're to the right, and a negative number means you're off to the left. Left of where? Left of dead center, which we call the origin. That point has coordinates of 0, 0, meaning it isn't any distance to the left or right, or up and down. The second number tells you your vertical position, and for that number, up is positive, and down is negative. So let's see how this works when we have some actual points. Point A, starting from the origin, is 2 units right, and 1, 2, 3, 4 units up. So 2 to the right, 4 up. Those are both the positive directions. So the coordinates of that point would be 2, 4. If you want to write +2, +4 until you get settled in and used to writing these, that's fine. It means the same thing. So 2 horizontally, 4 vertically. Point B is horizontal first. 1, 2, 3 to the left, which actually means -3, comma, and vertically, well, no distance at all, it's dead center, so you say -3, 0. 3 units left and no units up or down. Point C, 1, 2, 3, 4, 5, 6 units to the right, and then it's 1, 2, 3 units down. So I'm about to make a mistake, see if you can catch it. What's the matter with that? Something's missing. The 6 is okay, but because it's 3 units down, our y-coordinate should be negative. 6, 3 would be 6 right, 3 up. It would be about here. C is 6 right, 3 down. D is, let's see, well, it isn't any number of units to the left or right, so our x-coordinate is 0, and our y-coordinate is 1, 2, 3. Again, that's 3 units down, so we call it a -3. Notice these 2 points, which are both 3 units down, are even with each other. Any points that are lined up like that, you could expect one of their coordinates to match. And point O, I kind of ruined the surprise here because I mentioned this at the beginning. Point O for origin is the very center, and its coordinates are 0 units left, right, and 0 units up, down. So if you're right in the middle of the grid, that's the origin, and its coordinates are 0, 0. Now they get into quadrants. There are 4 quadrants here, because a quadrant means a quarter of something, and they are, in the top right is quadrant 1, and then as you go counterclockwise, the quadrants go up. So over here is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. They say the point in in the second quadrant, so here's our second quadrant. The only point in it is E. What are its coordinates? Well, 2 units left would be -2, and 1, 2, 3 units up, that's a +3. So -2, 3 are the coordinates of point E. If you were eyeing point B and thinking, well, wait a minute, that one's in quadrant 2, it's not. It's right on the line, and unlike tennis and volleyball, in the Cartesian coordinate system, on the line doesn't count. This point is not in quadrant 2 or 3. Next, they say coordinates of the point in quadrant 3. Here's quadrant 3, and again, there's only 1 point in it, and it would be F. What do you think for the coordinates of this one? Horizontal first, then vertical. It's 4 to the left and 3 down. So this isn't right. This isn't correct yet, but it's close. What's the matter with that? The horizontal should be negative because we're going left, and the vertical vertical should also be negative because we went down. Left and down are both considered negative directions. Right and up are the positive ones. And complete the following table using positive or negative. They're not talking about points now, but entire quadrants. If you're in quadrant 1, if you're anywhere over here, then your x-coordinates are positive, and your y-coordinates are also positive. If you're in quadrant 2, what's different? If you're in the top left, well, if you go left, that means your x-coordinate's negative. You go up, so your y-coordinate's still positive. Quadrant 3 is left and down, which would mean negative and negative. And quadrant 4 is to the right, which is positive, and down, which is negative. So every quadrant has a unique combination of plus and minus when it comes to its coordinates. When you see a point like minus 2, 3, you can instantly tell, okay, that's left and down, it's going to be in the bottom left quadrant. You can immediately get an idea which quarter of the Cartesian plane that point belongs in, and then you start counting your 1, 2, 1, 2, 3,